Hey everyone, it's that math magician, and on this video we're going to take another look at the law of sines and how we can use that to help us solve for an unknown side or an unknown angle in a triangle. Now hopefully you've watched the previous video before this where I introduced the law of sines. If you haven't yet, I would check that out because I'm going to assume that you watched this already while we work through our example problem that I have here. So we see here that we have a triangle here on the left side where we have some measurements of some sides and some angles. Just a quick recap from that previous video. Remember that capital letters represent the angles on this triangle and that the lowercase letter represents the sides. So I see here that I have angle A, which is represented by theta. Looks like I'm going to want to figure out what that angle is. I see that the side opposite of it, little a, is represented with 63. I see that I do know what angle C is. It's 29 degrees. And I see that the side opposite of that, which would be little c, is also 157 units. And then I also see that over here, side B is 213. So the question here that we're trying to figure out is, what does angle A equal? We want to figure out what theta represents here. And I think this is going to be a great candidate for us to use the law of sines. Again, this is a non-right triangle. I do not see a right angle in there, which means that we can't use our normal trig tools. We cannot use Pythagorean's theorem, sine, cosine, tangent, none of that good stuff that we hopefully feel really confident about now. Instead, I'm going to have to use law of sines. So what I'm going to do is I'm actually going to keep it as it is. I'm going to erase the terms that I actually do know the value of, and hopefully I'll then be able to figure out what I can use to solve for A. So I see here that angle A is represented by theta, so I'm going to switch that out to be sine of theta. Now little a, remember little a is the opposite side from angle A. So that would be this side over here, which is 63. That is what little a equals. Remember, the lowercase letter and the capital letter, they are the angle and the side that are opposite from one another. So if I'm using angle A here as theta, underneath it, I'm going to write 63. All right, let's see. Sine of angle B. Well, I do not know what angle B is, so I can't change that. But I do know that side B over here, little b, is equal to 213. So I'm going to go ahead and write that down right there. And then finally over here, we see that sine C of angle C. We do know that angle C is 29 degrees. So I'll go ahead and write that out as 29 degrees over side little c. Remember, the side little c is opposite from the side big C. And I see that right there, little c is 157. So again, normally when we're using law of sines, we do not use all three fractions because we're just interested in using two that will allow us to find what we're trying to solve for. Now remember, I want to find out what theta equals. I'm interested in figuring out what angle A is. So I definitely am going to want to use this fraction because this fraction is going to help me solve for theta. Now looking at the other two fractions that I have, I need to pick one of those fractions where I know both terms. Okay, do you see that here with angle C and side C? I do know both of those values there. So that is going to be a great fraction to use to solve for theta. I cannot use the B, the angle B and the side B because I don't know what this angle is. And if I were to use this fraction here to try to solve for A, I would actually end up with two different variables. I would be unable to solve that problem. So we are not going to be using that fraction there. I'm only interested in the fraction that involves my side and angle A and my side and angle C. So now that we know that those are the two we'll be using, let's go ahead and set them up equal to each other because that's what this says. It says that sine theta over 63 equals sine 29 over 157. So I will write that out. Sine theta over 63 equals sine of 29 degrees over 157. At this point, all we have to do is cross multiply and solve. So I'm going to go ahead and cross multiply this so I can start to get theta by itself. Let's see, 157 times sine of theta will become 157 times sine of theta. That will be equal to 63 times sine of 29 degrees. So far, so good. Remember, I want theta by itself. Right now, I have 157 multiplying that. So I'm going to go ahead and divide both sides by 157. By doing that, the 157 on the left side are actually going to cancel. And I'm just going to be left with, as I scoot this up a little bit, I'm going to be left with sine of theta equals 63 times sine of 29 degrees all over 157. Now I can't just put this into my calculator, right? I can't just put that expression in just yet because I'm trying to find out what theta is. And right now we have a sine that's attached to that angle. So what I'm going to need to do now to remove that sine is I'm going to need to do inverse sine so I can figure out what theta is going to equal. Okay, remember, back just like we did with right triangles, I can use that same idea here. I want to get rid of this sine. To get rid of that sine, all I need to do is take the inverse of both sides. When I do that, I'll end up with the inverse sine of 63 times sine of 29 degrees all over a 157. That is a mess. I agree. You're probably looking at that going, wow, that's pretty complicated. And it is. But thankfully, we have a calculator that will allow us to just enter that in, and it will actually give us our approximate answer for angle A, or theta, which is what we're calling it today. So that's what we want to enter in. A quick note, because I know I see this mistake comes up a lot when students are working through this. Just because you have an inverse sine out here and a regular sine inside, they do not cancel out. You cannot do that. The math police will come and grab you if you try to do that move. That is an illegal move. You cannot do that because we have that 63 also attached there. So they're not going to cancel away. So what we get to do now is we get to input that into our calculator. I'm going to use the free online calculator from Desmos.com to help me solve this problem. So I have my Desmos calculator here. I need to press the inverse sine button. I'll go over to here to where it says function. I'll press on that, and I see that I have my inverse sine button right there. So I'll click that button. I'll go back to the main panel, and I need to put a fraction in. So I'm going to push this button here, which will allow me to enter a fraction. And on the top, I'll enter what my numerator is. 63 times sine of 29 degrees all over 157. I press enter, and we see that that missing angle ends up with a value of 11.21, I would say 8 degrees. 11.218 degrees. That is our missing angle here for A, and we were able to solve that using the law of sines. I hope you can take a moment just to appreciate the fact that without law of sines, this is impossible for us to do. We need the law of sines. The law of sines allows us to find missing sides and missing angles for any triangles, not just a right triangle, in this case, for our triangle on the left.